Hello students, we are solving the IB Math EA HL past papers and currently we are solving IB Math EA HL May 2022 paper 2 time zone 2 past paper. Today we will be solving the question number 8 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 8. The maximum mark is 7. Rachel and Sophia are competing in a javelin throwing competition. The distances are meters thrown by Rachel can be modeled by a normal distribution with mean 56.5 and standard deviation 3. So, R is a normal distribution variable with mean as 56.5 and standard deviation as 3. So, the variance will be 3 squared. Okay. And the distances S meters thrown by Sophia can be modeled by a normal distribution variable. So Sophia S and N with mean 57.5 and standard deviation 1.8. So variance 1.8 whole square. Okay. And now they are saying in the first round of competition, each competitor must have 5 throws. To qualify for the next round of competition, a competitor must record at least one throw of 60 meters or greater in the first round. In the first round, they are having, each of them is having 5 throws. And they should be throwing at least once 60 meters or greater. Okay. So, in order to qualify for the next round. And find the probability that only one Rachel or Sophia qualifies for the next round of competition. So, okay, first of all, let us find what is the probability of R getting being greater than or equal to 60. 60 meters or greater. So it will be R should be greater than or equal to 60. So this should be equal to, using the calculator, it is menu and then probability distribution, normal CDF. 60 should be the lower bound. The upper bound is a series of nines. And for R, the mean is 56.5. So it is 56.5. And the standard deviation is 3. Okay. So we are having this probability as 0. Now this is not the final answer, so I won't be taking up to 3 significant figures. This is very important. You give the final answer up to 3 significant figures, but for intermediate calculations, never take an answer up to 3 significant figures. Okay, you take more number of digits, at least 4 to 5 digits. Okay. So 0.12167 I can take 0.12167. Okay. 0.12167. Let me see once more. 0.12167. Okay, fine. 7 and 2 6. Okay. 2 6. Okay, fine. And let us find the same for Sophia. Equal to probability and distribution and normal CDF, and lower bound is 60, upper bound is a series of nines, and the mean is 57.5 and the standard deviation is 1.8. Okay, it is 0.0824333. 0.0824333. 0.0824333. Okay, fine. Now we have got up to this point. The probability of R being greater than or equal to 60 is 0.1216726, and probability of S greater than or equal to 60 is that. Okay, now let us come to the first round of competition where there will be five throws. Okay, 5 chances. So therefore, for this, there are 5 throws. So total number of trials is fixed 5. And what is the success? Success is throwing off 60 or more meters. That is the success. So its corresponding probability also is fixed for Rachel and for Sophia. The probability of getting a throw of 60 or more meters is fixed. And you can have only 2 outcomes. Either the throw will be greater than or equal to 60 meters, or it will be less than 60 meters. You don't have any third option. If there is a throw, there can be only 2 outcomes, greater than or equal to 60 meters or less than 60 meters. So only 2 outcomes. And the probability of success is fixed, and the number of trials is fixed, and the throwing of one throw is not dependent on the other throw. So, and these people, they who go for the competition, they are so very uh, well practiced, and we need not consider the case that after 1 throw or 2 throws, the Rachel or Sophia, they are getting tired, so that is affecting their performance. We do not have to think about those. They are performing well. In all the throws, they are performing equally well. Okay, and therefore we can assume that the throws are independent of each other. Okay, so uh, it should be a case of a binomial distribution, because the number of trials is fixed, the probability of success is fixed, there are only 2 outcomes, the trials are independent, so it is a case of a binomial distribution. Okay, since it is Rachel, so let me write R and subscript B, because it is a binomial distribution. RB is a binomial distribution variable where n is 5, and the probability of success is this one, 0.1216726. Okay, 1216726. Okay, and then we have to get that Rachel should be throwing at least one, which will be having a distance of 60 meters or more. So probability of RB greater than or equal to 1 is equal to, let us go to the binomial distribution. Probability distribution, this time it is binomial CDF. Number of trials is 5 and probability of success is 0.1216 1216726 1216726, and it should be greater than or equal to 1. So at least 1. Therefore, the lower bound should be equal to 1. And since there are 5 throws, you cannot have more than 5 times a throw of greater than or equal to 60. So the maximum will be 5. Okay. It is 0.477 0.4772643. 0.4772643. Once again, 0.4772643. And similarly, for Sophia, that will also be another binomial distribution, and the number of trials will be the same. It is 5, and but the probability of success will be different. It will be this 0.0824333. Okay. What did we do? First of all, they are saying Rachel and Sophia, they are the distance thrown um, will be normally distributed. They are normal distribution variables, and the mean and the standard deviation values, they have given that much. And they are saying that in order to qualify, means they should be throwing 60 meters or more. So first thing, what did we do? We found the probabilities of throwing 60 meters or more. Okay, for these two people, Rachel and Sophia. And then they are saying the first round of competition will be having 5 throws. So now we come to the binomial distribution portion, and we are seeing that the number of trials is 5, and we have calculated the probability of success. And in order to qualify for the next round, they should be throwing a distance of 60 meters or more at least once. So RB should be greater than or equal to 1. It should be 1. It can be 1, it can be 2, it can be 3, it can be 4, or it can be 5, but it cannot be equal to 0. Okay. It is not that if Rachel cannot throw a distance of 60 meters or more anytime, he will be qualifying. No, he will not be qualifying. Okay. So RB should be greater than or equal to 1, and we have found the probability. Similarly, we will be finding the probability of SP greater than or equal to 1. Okay. I'm sorry if Rachel is a cursed name. I'm sorry, I don't know. So SP is greater than or equal to 1. Is probability distribution, and again binomial CDF. Number of trials is 5. Probability of success is 0.082433. 0.082433. And the lower bound is 1, of course, and the upper bound is 5. 0.34, 0.3495, 0.3495 Let me check once more. 0.3495885. Right. Now, finally, they are saying, so this is the probability that Rachel qualifies. And this is the probability that Sophia qualifies. Okay. And now finally they are saying find the probability that only one of Rachel or Sophia qualifies for the next round of competition. So how can only one of them qualify? It can be in two ways. Rachel qualifies and Sophia doesn't qualify. Or Rachel doesn't qualify and Sophia qualifies. Okay. So, what will this be equal to? Rachel qualifies. It is this 0.4772643 times Sophia doesn't qualify. So it will be, this is the probability for Sophia qualifying. So doesn't qualify will be 1 minus 0.3495885. Okay. Or this plus. So this is, in case you are not being able to see, this was Rachel qualifying, Sophia is not qualifying, or Rachel is not qualifying and Sophia is qualifying. So the first one, this is the probability of Rachel qualifying and Sophia not qualifying. The Sophia qualifying probability is this, so the not qualifying probability will be 1 minus. Okay. And now Rachel is not qualifying, so it is 1 minus 0.4772643 times Sophia qualifying, which is 0.3495885. So what is this equal to? This will be our final answer. Okay. So let me just go to this part. Okay. So first is Rachel qualifying and Sophia is not qualifying. So Rachel qualifying is this part. Just let me copy this and this one, Control V. Okay, times Sophia not qualifying. 1 minus this one. Control C and this is Control V. Okay, or plus 1 minus Rachel not qualifying. Control C, Control V times Sophia qualifying. Okay, enter. It is 0.493 up to 3 significant figures. Now you see this is the final answer. For this, I will be taking only 3 digits to 3 significant figures. Okay. So 0.493 will be our final answer. 0.493 equal to 0.493. This is probability of only one qualifying. Only one qualifies. Equal to probability of R and S bar or probability of this. Okay. So this is our final answer 0.493 up to 3 significant figures. Okay. So students, this brings us to the end of this question number 8. We have solved question number 8. And thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And as you are seeing that I am uploading the past paper questions of the IB Math ESHL I'm providing you the solutions of these questions. And in case you're liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. And in case you have any doubt, any confusion related to these questions, these answers, these explanations, please do feel free to write to me. I will be clearing your confusions as much as possible. And we meet again very soon in our next session. We'll be solving question number 9 of the same paper. So till then, bye.